Hello, everyone.
Oh,
Okay.
sorry, let me just share the sound.
Okay.
All right, feel free to get started.
Hello, everyone.
We're far
We are
from
Firefume,
Perfume.
and we're also Team Deep Green. I would like to start us off by introducing my esteemed colleagues, Parker, Eugen, Nithya, and myself. We're also greatly indebted to our mentor, Mrs. Akshata, for her continued support throughout the project. So to give everyone a quick outline of what we'll be presenting in today's presentation, we'll start off with the problem, the solution, users, our competition, before diving into survey results, our demo, and finally, our future plans.
Imagine this. You live in a place highly prone to wildfires. Take California as an example. You've grown up experiencing at least one wildfire each year. Many of the places you used to visit when you were a child are no longer here. They've been burned down because of these wildfires, these inexplicable disasters that are a result of climate change. These disasters that tear apart what we love the most, our community. One of our survey respondents has a similar story. As a California resident, they say the places I used to love going to as a child are now completely black and ruined because of constant fires. Here are a few pictures showing us the before and afters of wildfires. Now this wildfire that you experience is only one in about 70,072 wildfires that happen each year. As a result, we lose about 7.0 million acres of land. However, it is not just the land we lose, but rather also our childhood memories and our fond stories that burn along with it. How would you feel seeing the places that you had your fondest childhood memories now destroyed? Apart from losing your places that you love the most and your fondest childhood memories, the spread, the health, and the financial impact are also three other major concerns regarding wildfires. Wildfires spread at a rate of about 14.27 miles per hour, and there's low awareness regarding the spread, so many residents and firefighters will be at risk and may not be able to attend their jobs. The health. Wildfires are responsible for about 25% of the air pollution in the United States, and one of the many air pollutants that they release is particulate matter 2.5, which is highly dangerous and can cause many respiratory illnesses in the future. The financial impact. Wildfires can destroy crops and farmlands, affecting farmers and their families and their main source of income. They can also be detrimental to the economy. A recent example was back in 2018, the California wildfires alone resulted in economic damage of about $148.5 billion.
With wildfires being such an urgent issue, it's important to deal with them. But how? One of the major obstacles to effectively fighting fires is a lack of reliable prediction systems. Currently, firefighters often find themselves using prediction tools that are either highly inaccurate or outdated. Introducing FireFume, an end-to-end high-accuracy AI-powered wildfire prediction system. Our model is trained on a dataset that includes 12 unique features, including elevation, vegetation, and wind speed, as shown in the image in the bottom left corner. Then it gives the next 24-hour wildfire spread. And on the slide, as you can see here, the first row on the top left corner gives our model's predictions. And on the second row, also in the top left corner, it gives the actual results. So as you can tell, our model fares pretty well. And just to give a quick technical overview of what our model is, it's a CNN autoencoder, which takes in these 12 unique features, including yesterday's fire mask, and it outputs today's or the next 24 hours fire mask. So then just to throw in a few numbers here, our model is over 90% accurate and far faster than other applications. Our prediction system will not only empower fire departments to more effectively deal with wildfires, but can also help farmers and other corporations forecast potentially disastrous wildfire effects. In our fragile world, entire industries rely on the very resources that wildfires threaten. And now I'd like to hand it off to Eugen, who will cover the competitive aspects of our product.
Thank you, Kai. Of course, while wildfire spread predictions haven't been explored as much as wildfire detection, there have been work done in this field. The most popular example would be Farsight, a robust physics/mathematical model that requires surveyors on the ground to collect the necessary information. While it is the most commonly used model currently, because of its requirements, it tends to be time-consuming and expensive, which may be fatal in a true wildfire scenario. In recent years, a few models have attempted to use computer vision as an alternative solution, such as Firecast and Agni, which have an accuracy of around 85%. However, while 85% is indeed impressive, we believe that we can't be content with this accuracy rate. The threat of losing our homes, losing our memories, losing our safe environment is too critical for us to rely on an 85% accuracy rate. These models tended to be made up of some simple deep learning algorithms, such as convolutional neural networks, which made us believe if we tried utilizing some more complex models, their accuracy may improve, which was indeed the case. Furthermore, we believe that our data will be much more useful in creating a quick and accurate model, as our data is made up of remotely sensed data, which can be quickly collected for analysis in the future. Our database is also more geographically comprehensive than the other models' database. Thus, we believe that the model will have more use cases worldwide. In terms of finance, many of our models are developed through the funding of Many of the other models are developed through the funding of donations by various relevant organizations, such as US Forest Services, and are typically provided for free after initial development. Thus, if we were to pursue further development, we try and similarly get donations to complete development before really releasing the software freely. Now, I'll hand it over to Nitya for the survey results.
Thank you. So we have a few survey results, and the two main responses that we received are one from being a California resident, anonymously stated the places they used to love going to as a child are now completely black and ruined because of constant fires. Another from being a Washington State resident, Miss Sophia, stated when the skies were orange/red in Sammamish and Redmond, Washington, where I live, and it was too smoky to go outside. Now here, Miss Sophia is referring to California state fires and how it's affecting her in Washington state, which is a few hundred miles away. So this shows that these wildfires can have a huge effect on many places, and whether that be like the hotspot or the places that surround it, it can have a huge effect within 100 miles or more radius. And we also conducted a few interviews, and our first one is for Mr. Jeff Freelick. And what are your thoughts on wildfires?
They're a reality and dangerous to people, life-threatening. Mm-hmm. It's making it more difficult to think of a home being a lifelong investment.
Yeah, we were actually looking into like some research, and turns out also affects like agriculture and like farmers as well, because like some land may be like really good and fertile in one area, but it may also be prone to wildfires. So there's always like that risk. And
this is going to become more and more of a big problem as we dry out.
Thank you, Mr. Jeff Freelick, for your interview and your time. Now we have another interview from Mr. Frank Su.
How important do you think wildfire spread prediction systems are to preventing the spread of wildfires?
Yeah, I think like if we can make it accurate, then it can be very important, because then we can like figure out, say, like which places are the most like strategic in terms of like stopping the fire.
Thank you, Mr. Frank Su, for your time and your input. What are your thoughts on wildfire? A few numbers, and one of the main questions that we asked in our survey was, do you think enough is being done to stop wildfires? And no one responded with the answer of yes. Everyone responded as either no or not sure, which means that more can be done to stop the spread or mitigate the risks of wildfires.
So for our application, we use Angular. It's a popular front-end web framework. By using Angular, we are able to make web-based apps that can be accessed on all internet-enabled devices. So regardless of what operating system your device uses, the app can be accessed in your browser. The machine learning model is integrated straight into the web app, allowing users to make next-day wildfire predictions in real time. Hello everybody, I thought I'd make a quick video going through some of our demo code. So here we have our Angular app. This is where we have all the integration with TensorFlow.js, where we have our model that can make predictions. So here we have a bio, and it just goes really briefly through what libraries we used, our model architecture, and we have our mission. And it's very simple, really. We want to protect human life, and we want to create an AI solution to predict wildfire directions and growth, and so on. So here at the bottom is where you'll actually be able to make these predictions from our test data set. In the future, we want it where users, whether you're a fireman or a first aid responder or some type of government employee, you can make these predictions by selecting a photo and then clicking this to make a prediction. Now these are all features that we're still really working on. For now, this is just a test data set prediction. off of our data set, but we're really excited about our project and we hope to have this integration finished real soon. So to summarize, while achieving high accuracy for our machine learning model was an important milestone for us, we have many more plans in store for our project. For example, we want to extend our current functionality. We want users to be able to submit their own photos, either from the ground or from a satellite, so they can make their own predictions. Additionally, we'd like to add geolocation features to our web app. This way, users can find mapped out wildfires in their specific area. This way, we can see the fire's growth predictions over the next 24 hours, and users will know when to evacuate the area. So to summarize, by building our wildfire prediction app, this is our team's effort to leverage our machine learning skills into an environmental issue that is way bigger than just us. While we know we will not always be able to avoid wildfire devastation, being able to use scientific data and cutting-edge machine learning architecture is imperative to understanding the complexity of the issue. We're really excited about FireFume, so thank you for your time.
Thank you very much. What a wonderful presentation.